Hello, and welcome to the video on handlers inside of the state machine control scheme that we're talking about in FRC programming. So, right now, we're here. We're looking at handlers in our state machine. And remember, the combination of manager and handlers is going to replace commands. So we're not going to use commands anymore. And we're going to go from the bottom up, because I think it's easiest to understand here, because everything above needs all the stuff below. And as you can see, subsystems are exactly the same. That's why we're starting at handlers and not subsystems. So subsystems are the exact same thing that they were with the command-based paradigm. You don't need to change any code, you don't need to refactor anything, you can use it exactly as is. And of course, updates, you'll see, are exactly the same, right? All your triggers and Xbox controller and joysticks and flight sticks, they all have the exact same code. So right now we're here. We're with the handlers. Now, I did lie a little bit. You will have to add a bit more code to your subsystems by implementing this interface. And the methods are pretty easy. So the stop method just stops all movement in that subsystem. So if you have motors, you have pneumatics, you have, a servo, it just stops all the movement from all those different actuators. Then you have get initialized. This is something you want to check at the start of the match, or really as you load on. Right, so this is checking, are we in our starting configuration? Right, you read an encoder value from, let's say, a pivot mechanism, just to make sure, all right, we're where we're supposed to be. If you have a camera on your robot, maybe you want to read the camera and say, all right, are we in our starting position for auto? That's things you'd look at in your get initialized method. Then we have the check subsystem method. And check subsystem is going to be run during teleop, and it's going to just check all the different variables and motors and sensors as a sort of sanity check to make sure that they are in an acceptable range. So if you have a flywheel mechanism, you probably want to check, all right, is that within a reasonable RPM? So if it's reading 50,000 RPM, well, you probably want to stop movement there because something must have broke. Or if you have a limit switch as a hard stop for one of your mechanisms, if you hit that limit switch, you probably want to stop all the movement. So those are examples of what you would put in check subsystem. So again, check subsystem gets run every single loop of the scheduler. It's something you run during auto and during teleop. Here we have our second interface for the handler. This is where we start getting into the state machine part of the video. You see here, these are all things that are just going to be useful and we're going to be able to implement very easily, which is why I put them in. But there was nothing about states within these methods. They were just checks. Here we have actual states. So starting off at the bottom, we have set desired state. And you'll see how this will work, but it just sets the state that the handler is in. Now, if set desired state is setting it to a state that it's already in, well, it just does nothing. But if it's changing it to something other than the one it's in, so we're setting it to a different state, we want to handle that transition between states with this method, the handle state transition method. It does exactly what it sounds like. So if we're going from intaking with an over bumper intake to indexing the game piece, well, we probably want to retract that over bumper intake. So that would be something that gets handled with the transition between the intaking state and indexing. And finally, we have update. Now, update, we're going to use kind of interchangeably with the periodic method, because the handler is going to extend the subsystem base instead of the subsystem itself. And the subsystem base class is provided by WPILib. You should be familiar with it. So the update method will be called in the periodic, which is why we can use it fairly interchangeably. So these are things like updating the speed of a motor if you're reading it from an encoder with a PID controller. right? It's going to have a new speed every single time the value changes, so you want to update that every loop. Or if you have a vision-based aiming system, you definitely want to look at that every single loop to make sure you're still on target. So here we go. This is the layout of the handler. And this right here is the state that we're talking about, the states. So we call it a substate because handlers handle a subsystem. So subsystem, substate. So this setDesiredState method would be called by the handler to change the state that it's in, or the substate it's in. And right now, you can see by the solid arrow, it is in the idle state. So the handler takes in two inputs, and that's from sensors and from the manager, which we'll talk about later. You'll also note that the handler handles just one subsystem. It also can only be in one state at a time, because the different states have different behaviors. So if we're in the idle state, the handler is going to control this subsystem differently than if it were in the foo state or the bar state. So to give it a real world example, we'll go back to that over bumper intake. If you're in the intaking state, it's going to control that intake differently than if it's in the stored state, where it's just stored inside your robot. So let's run through what happens when you go and try to pick up a game piece, starting here with these inputs. So the manager is going to be managing all the inputs coming from the controllers. So I press the X button, and the manager says, okay, set desired state to the handler, and say, let's go into the foo state, because the foo state is how we intake. So now we're intaking from the ground, because it's probably a very common problem that'll stay relevant for a while. And that's going to change the way that the handler is controlling the subsystem. So now, instead of just doing nothing, the handler is going to have the subsystem outside of the robot, and it's going to be having the rollers constantly running, waiting for a game piece. Then, the sensors, if you have a beam brake sensor inside your intake, because that's a pretty common one, or maybe a proximity sensor, when this sensor goes and reads, oh, there's a game piece in there, the beam got broken, or the time of flight sensor, indicated, oh, really short time of flight because it bounced off a game piece. It's going to go and call this setDesiredState method again. And so the handler says, okay, we're going to set the desired state to bar, because this is going to be the indexing state. But because bar is different from the intake state, we're going to handle that state transition and pull our over bumper intake back inside of our robot. So now, we're no longer in the intaking state. We're over here in the indexing one. And so it's going to go and it's going to index it. And the handler is going to say, oh, okay, we're done indexing after X number of seconds. And finally return back to our good old idle state. So the things I really want you to take away from this is the handler can only be in one state at a time. And while it's in any individual state, that's going to change the way it controls the subsystem. Also, the inputs that it takes in, they aren't voltage readings, they aren't positions, they aren't, percentages of power, 100%, 50%. They're just states. All we're saying is, handler, go to this state, go to that state. There's nothing in here about specific positions or speeds. The inputs are only states, and the handler just handles the rest for us. So really, it's sort of a extension on top of the subsystem. It's a layer of abstraction to make it easier for us to deal with the subsystem. We don't have to worry about values, we don't have to worry about the behavior of the subsystem or the actual methods that we wrote, the setters and getters. The handler just handles it all for us, and when we want to control this subsystem, all we do is tell the handler the state we want it to go in, the behavior we want it to have. So the next thing you really want to learn about is probably the manager. That's the next most important one. As we saw over here, that is the next step up on our little chain. So come back and watch that video.